Hello hackers, welcome back to another alpha session. Today we are going to explore a bit on MCP protocol, and it's not going to be a tutorial, it's going to be a demo. Today I'm going to show how to develop an MCP server to trigger your malware from your LLM host and how to get the reversal using this. So basically it's just a demo of showing how to make use of LLM's natural language capability that converts your natural language to the crafted function that's going to work over the MCP protocol. So we are going to make use of MCP Streamable HTTP option for this one. If you have seen, and if you okay, basically what we are going to do is we are going to craft an MCP server over Streamable HTTP to trigger a malware called BPF door. If you don't know what about BPF door is a Linux malware. Basically, it's connected to the APT group Red mentioned. They have created it, and this was there on the news for till last week actually. I think last week South Korean government released an investigation report regarding an incident happened due to this malware in the South Korean telecom. So they had a data breach due to this malware. Regarding this one, this very stealthy malware, how it works is it uses a classic BPF filter for filtering packets, and then how to trigger is very interesting. If you the source code is available, I don't know, it's a leaked source code or a deliberately leaked published one. A part of it is available. If you have go through the code, you can see that it uses some techniques that is very I can say very genius techniques. I really recommend this malware code if you are interested to learn more about Linux internals. So how in a short how it works is, as I said, it uses BPF filter, classic BPF filter as a packet filter, and it accepts only those packets that is designed for this malware. So you have to craft a specific packet that this malware accepts. Now then it triggers reversal or bind shell option based on a password that is pre-configured inside the malware. So if I talk more about that, you will get confused. I'll show the demo how you can trigger it. Inside actually the BPF door malware is using a lot of techniques called it is basically the leak code version is using RC4 encryption for the communication channel between the listener and the infected malware machine. Yeah, basically it has a lot of other features. If you search for the BPF door malware analysis reports, there are so many companies did this. Almost all the leading AV vendors and EDR vendors have reports about this one. So you just go through that. Here I have gone through the code, and I did develop a listener for this malware, and I made another program that crafts the packets and helps to trigger the packet on the infected machine. So I did normally in the sense I did that manually by every program. So today I'm going to make use of the MCP protocol and its capabilities to trigger this malware for me. So MCP, if you ask me what MCP is, it's open standard designed to simplify how AI applications like LLMs to access and utilize external data, tools, and other systems. So basically this is an image, and this image is taken from their website, core website, MCP protocol, model context protocol.io. So how it works is like you'll have an MCP host, you have an like LLM host with an MCP client that is capable of communicating over MCP protocol to your MCP server. So your MCP server can reach out external resources. It doesn't matter for the host or the client. So if you want to do some actions that your LLM can convert to natural language, then I mean, basically you can do whatever you want. It depends upon your requirement. So these are after what happens inside the MCP server is a normal external resource accesses, or external, you're reaching out to your record systems to communicate. That's all about it. Basically it's a kind of protocol that helps you to helps other LLMs to communicate, I mean any LLMs to communicate your resources or local machines or remote machines through the MCP server that you develop. So let's go to the demo. I will show the demo, then it will be more clear for you. For the demo purpose, I already, as I said, it's not going to be a tutorial on this one. Definitely I'll create a tutorial for how to develop MCP servers for offensive and defensive purposes. Here is a sample demo. And one more thing I had to consider for this demo, when I developed the core function initially and tested with Cloud API, Cloud Desktop App, it showed the function. I listed out everything, but when I tried to use, instead of the parameter that you see here, destination IP and destination port, I use target IP, target port. Then instead of receiver IP and receiver port, I use listener IP and port. Then protocol, I use packet type. Then I had a secret that was passed as parameter in the beginning. So when I tried this one in Cloud was saying it is unethical to do this kind of operation, and it categorized my request as something related to network pen testing or some other category, and it was blocking me by saying that it can't do that due to the ethical considerations. So that was a challenge for me to do the demo. So what I did was I completely changed all the, this is kind of bypass that you can try even if you're testing LLMs or any these kind of stuffs. I completely changed the names of the parameters. Like instead of the initial name was trigger BPF door, instead of connectivity test, then instead of target IP I changed destination IP port. So I made a field to the LLM that using the intelligence that it has, it may think that it is going to, I think it's going to think that it is going to do something just for testing the connectivity. That's how I did bypass it. You can try different methods, and yeah, of course, instead of when I was trying to send the password through the MCP server, it was saying that it won't allow me to send the password over that because of blah 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 reasons. So I had to hardcode the password here. Anyway, this is going to be a function exclusive for TCP. So if I want to trigger UDP packets, I can create another function and make use of that to do that. So that doesn't matter for me here. Basically, I just need destination IP port and the protocol and the receiver IP and receiver port. This is my listener IP and listener port. So what it's going to do is actually, as I said, BPF door is working in a way that it always expects a packet that has a receiver IP, receiver port. That means C2 IP and C2 port, and it expects a signature and a secret. Secret in the sense is a password. This password should be there for reversal. I mean, for the code that I'm going to use, this is a password used inside for reversal. There's another password for buy and shell that I'm not going to show here. The signature should be there. These four parameters: receiver IP, C2 IP, C2 port, signature and secret should be there as a inside a packet payload. So the malware is going to decode this package and pass the packet, and it checks for these parameters. Only if these are there, it will trigger the reversal. So then after that, I just craft the packet and send it. Just send it means I'm not using SCAPI or any other external libraries to craft the packet, just socket connectivity just to send it. that's all for the function. For as for this one, MCP server, I'm using fast MCP, and I'm just mentioning it has to listen to all port here, because I'm going to open this to my LLM. So I'm just making it available on 000, and on this port, if you don't mention this one, is going to be the host going to be 127.0.0.1 and port I think 8000 or something. And the other important part here is you have to say when you are running the server, you have to mention the transport is Streamable HTTP. The other transport is using is called stdio, and there was something SSE or something that is, I think that's deprecated now. It's not used by anything. But the main other thing is when I say stdio, stdio is a normal MCP servers that you see a lot, because it needs to be in your local machine. It needs to be in a machine where you are going to, when you are going to access it, it should be in your machine. It's going to have a lot of dependency issues if in real time, if you are trying to develop a server. Every server needs to be on your local machine, and it needs to be with all the dependencies inside the server. So this is a better way. So yeah, you can try with even the same function you can try with how to say, with your local MCP server. So basic idea here I'm going to show is how we can deceive the LLM or bypass its restrictions to trigger the malware. So here is my infected machine. I have my malware here. I'm going to run it, and I'm going to start one TCP dump here to check, just to ensure that my LLM can send the packet to here. So the packet listener is ready, and I'm going to run the malware. So the malware is running. Yeah, it disappears. Actually, most of the operations are very stealthy. It has a lot of other functions other than I mentioned here. And I'm planning to take another exclusive video for BPF Door, how to explain all the functionalities and how to develop a listener for that. That itself is a big topic, in fact. So what I'm going to do is I have already developed a listener. This is developed in Golang, and this is basically going to listen on this one using this keyword. Basically it is for reversal. So it's listening here, and so here you can see the password I use here, this one, and this is going to be my C2 IP endport here. As per my new deceived function, it is going to be receiver IP and receiver port. So what you have to do is you have to run this one using UV and trigger.py. So this will be running here, and what you can do is you can test it using even without the LLM stuff, using a tool called MCP inspector that comes with this one. And I think I already has running. Yeah, my inspector is already running here, and I already connected. See, I'm just trying to send the packets. Okay, I mean, I'm not going to show the sending the packet here, because this may trigger my reversal. I want to send this packet, the same thing from, but you can use this MCP inspector tool to check it, your functionality, even before you go to the LLM stuff to test it. So yeah, I just showed you that there's another tool. You can make use of this one. It's very simple. The only thing is when you are checking it, just change by default it will be stdio, the transporter type. You have to change it to Streamable HTTP to check it, and you have function here, and you I'm exposing this as the tool. So the MCP inspector will show all the tools after connecting. What are the tools it has? Then it it show, you can click the tool name here. See, the connectivity tester is my tool name that I mentioned here. This function has these parameters. If you want to test it with the inspector, you can test it, but for this demo I'm not going to test it using this one. This is just like a, what to say, debugging state. When you're developing, you can make use of MCP inspector. So here we are going to do the real stuff. So here is it. If you want to add this, I mean, if you want to add this server to your cloud, you go to the file and take the settings and come to the developer option. Just click on the edit config and it will open the file for you. So this is a file that's going to change, and the content of the file should be something like this, and this is where my this name, you can give any name according to your this one. nbx is a command that's going to help me to reach out my, I mean, basically MCP remote is going to help me to reach out to my HTTP, streamable HTTP server, because cloud by default doesn't support this one. So there is another thing that you have to use is MCP remote, and for that you have to install a lot of other dependencies. That all these things I will cover when I'm going to start a tutorial exclusive for this one. So for the just for the demo purpose, I'm going to say that this after editing this configuration, what's going to happen is cloud will have I mean, cloud LLM will have, I don't know, it's cloud or something. Okay, I say cloud. This is going to have my MCP server visibility, because this is my IP and this is the port that is listening. And MCP means basically we the cloud, I mean, the LLM is going to send a post request to this endpoint with the parameters that I mentioned inside the function. So you have to, when you are testing this one, when you don't have HTTPS, always try to make use of this one. And it's not going to be, and I don't recommend this like in a production level stuff for doing, because now it doesn't have any kind of authentication related to Streamable HTTP. But there are some, I didn't use that here because it's just for the demo. I just wanted to show how to deceive LLM to do some malicious actions. So you can, your server may be doing some offensive stuff, but the LLM doesn't know that. If your LLM come to know that from, if it comes to know your function is doing some malicious activity from your parameters or arguments or function names, definitely the LLM will block. That's what my experience was. Like, I had to do this multiple times because everything was working perfectly with the MCP inspector, but when I came to use cloud LLM, it was blocking me by saying that it was unethical. The activities to connected to some other network pen testing and other stuffs, and I have to use network pen test exclusive tools for that. Don't use LLM for that. So many blah blah stuff. So that's the main reason I changed this one, the names of the functions and parameters, everything. So I'm just closing it here. Now what I had to do is I have this one here. Yeah, for some strange reason you have to completely exit this one, cloud, otherwise it won't show. Normally my expectation was it will come here. So normally if everything goes well, it should come here, but it won't come here until you completely kill it and reopen it. So I already created one bad file for killing it, so it just closed. I had to reopen it. So now it came here. Hopefully it should Yeah, see, my connection test was a name that I have given for the my MCP server inside this configuration. So it is here. I just selected it. I mean, anyway, it should be there. So now cloud know that my MCP server is there. So when I'm going to, so the next thing is how to tell cloud that to do this for me. So here are a couple of things that you have to. So where is my listener? I need this here now. So many things going to happen. Here the malware is running behind the scene here in this one, and I'm just listening with the TCP dump just to ensure that my packet is reaching, and I'm saying a prompt here. Oh, sorry. So same time you just listen here. If everything goes well, this will get reversal from the infected machine when I'm sending a prompt here. So what I'm saying is test connectivity to this IP, this infected IP on this port using TCP as protocol with the receiver IP as this on port 444. So this I mean, if everything goes well, this natural language stuff going to be dictated by LLM with my MCP server, and it has to pass everything properly. So let us try. It is trying to get it. See it did detect it, and it converted my this natural language request to my MCP server request. So it asks you like what do you want to, I mean, is this stuff is correct or not. So you can decline, or I mean, if you give allow always, it always allows it without asking this one. Oh, I think my video stuff, yeah. So this is a message that you see here when you after LLM is detecting it. So I'm just giving allow once, and see here you see the packet is I send the packet to this area, and this says the testing connectivity has been successfully completed. And meantime I come here, see I got the reversal here. So what happened here is the LLM has no idea what the function was doing. I completely deceived it using this prompt. It thinks that it is testing some connectivity, but behind the scene I crafted a packet that triggers my malware that helps me to get the reversal here. So if you check, I mean, like basically you got the shell as root. So if you come here and type IP address, definitely it should be 160 because this is my infected machine. So that was my target, and I send a packet to here, and I got this one. So what I don't know what I had to say about this one, the MCP server usage. And you know, this is a buzzword that is around everywhere. If you check any latest stuff, everybody is talking about the MCP servers, and basically they are talking about the MCP server using STDIO on the local machines. Even that where you can deceive the LLM to do this for you. I just use HTTP because I'm planning to do more stuff on HTTP, Streamable HTTP and MCP servers to automate more stuff for me going forward. Yeah, I will come back with another exclusive tutorial for MCP servers and how it works and how to get connectivity and how to automate your stuff. Plus, yeah, definitely I'm planning one exclusive session for BPF door, how it works and how did I develop the reversal handler for, because it's not a normal reversal handler. You have to do the same encryption decryption techniques that is used inside the malware to show the result properly like this. So that's all for this demo. That's what I planned. Yeah, that's it. Nothing more on this one. So stay tuned for more on MCP, offensive operations, and yeah, other malware related stuff. See you soon with another video.